So we're going to talk about the futuristic ideal mode, or what we call as a futuristic jet and a personal drone deployment model. So the basic assumption which comes out of it is we're going to use the emerging technologies to embed this kind of a solution to overcome a problem. The problem currently is looking at traffic congestion for one. Second thing is saving time, cost, and maybe even sustainability would be one of the reasons for this kind of envisaged travel. So central aircraft, which is we call as a big mother jet, carries the passengers to a vicinity, and instead of landing, it may land in space stations, not maybe 5,000, 6,000 feet in the air. Okay, then we have the autonomous drones transport each individual to the rooftop directly, so that they can reach home faster, not getting involved in the landing, time spent, and other what do you call time saving or time spending windows which are generally seen in the travel. Then also it will be useful for specialized travel, in the sense you're carrying people in emergencies. This kind of travel will be very useful, and it leverages the emerging technologies like AI, sensors, cloud computing, edge, and cyber security. Then can be evaluated according to the four what we call LOs of the chapter. Okay, so that's the urban road congestion, emissions, and the last minute efficiencies are increasing. So that's the problem statement we have. So one of the concept is to use a central jet and AI powered drones for sustainable last mile air mobility, so you can directly land on the roofs of your homes. So what is the scenario? It combines mass transport with personalized last mile drone delivery. It bypasses the congestion, okay, reduces emission and increases efficiency in terms of cost, in terms of time saved, and also comfort, okay, and sustainability, of course. All the sustainable goals can be easily met. And it introduces complexities in regulation, infrastructure, and trust. That's one of the challenges, but there are other ways of looking at these challenges and to overcome them with modern technologies. Okay? So that's the picture we are envisaging. This is the individual passenger drones sliding from the mother jets directly to the rooftop. So what are the emerging technologies we are looking at? So AI and ML for the drone autonomy, maintenance and matching. So what type of drones are required and how they can be glided to their destination. Then the sensors like LiDAR, GPS, radar for safe rooftop navigation. Then we're looking at a 5G, 6G gambit for low latency communication between the jet and the drones. Then cyber security for system integration and passenger safety. Okay, and then we're looking at digital twins for simulations, edge plus cloud for real-time processing. So as you see, digital twins is the latest technology which has come up in terms of supply chain or in terms of transportation, where the scenarios can be built up on duplicated models, and the solutions can be readily built up in real time, navigating the safety and the cyber security threats. We are looking at the research. What do you need to do to get the impact? So we need to research into the urban air mobility platforms and systems. Then what are the positives? Is reduced commute, cleaner air, personalized mobility. The negative we need to go around is the noise, safety perception. Basically, it's a perception mindset. People need to be comfortable to travel in this kind of environment, and of course, a lot of testing and trials need to be done before we really come to the commercial part of it. And visual illusion and privacy, and the equity challenges, early cost, and we limit the accessibility because it may be a costly endeavor, but with the way the technologies and wireless trends and the GPS are going, it may not be a far-fetched solution in the near future. So we're looking at the hydrogen development stage. So we're looking at rooftop landing, sensors, path planning, individual for the individual drone slidings, then the passenger ID and assignment, biometrics, matching. This very much already started, so it can be in advanced level. So whoever is traveling can be captured on this, and it can be confirmed that they are going to their homes and not a GPS. So it's a match between their home image and their own image, and they can be glided through using those matrix. Then the iteration, the drone deployment and the robotic docking systems need to be set up, that is in the space as well as in the rooftops, and there need to be connectivity between these at all times in real time, and real-time air traffic and AI fleet management, what we call as universal intelligence, need to be worked on. If you're looking at a flow chart, so we can look at cruise at altitude to target area, then pre-landing protocol activator, then individual drone personalized assigned areas to be done, then all the biometrics, everything done, then the mid-air vertical deployment from the jet bay, then drones navigate via AI to rooftop coordinates, landing sensors confirm the safe descent, and passenger disembarks on the rooftop, and the drone returns to the nearest base or the charging dock. So this flow chart we are looking at, process chart we can look at. Okay, what are the ethical considerations? Safety and crisis management are the top priorities because passengers are involved in this. That's why the twin technology is very much required to do. Okay, so we can replicate the scenarios and look at what's going on and what not to build it into a full system. Then protecting the privacy and avoiding surveillance misuse is another priority area. Then fair and inclusive algorithm design. So these are all technology based, which is quite easy in the current scenarios. Balancing environment and manufacturing trade-offs. So cost involved need to be worked out and the analysis made before the commercialization starts. Okay. Then the social impact is the public acceptance, equity in access, community impact. So economic is the valuation and the investment and the operational cost, and it also gives job opportunities because there will be a huge jump in technology as well as in transportation in terms of time saving, then what you call as in terms of global travel, okay, and ease of traveling, then legality, airspace regulations, liability certificate standards need to be put in place, and data protection always, the compliance of it, the GDPR and the cybersecurity laws need to be formed up before it's commercialized. So conclusion is the Big Jet Plus drone system is a futuristic scalable transport model. Then the technological feasibility must align with social responsibility. Then the success hinges on the holistic design, stakeholder alignment and trust. So this is primer setup looking at the transportation model.